Welcome to 12.1 Representations of Three-Dimensional Figures. So this is your last note packet for the year. Chapter 12 will be our last test. This front page will be given to you on the test with all of your formulas, as well as the formulas from Chapter 11. You'll be given both of those. So we talked about two-dimensional figures in Chapter 11. Now we're going to go to 3D figures in Chapter 12. Skim the examples for Lesson 12.1. Predict two things you will learn about representations of three-dimensional figures. So one thing you might notice, example 1, it says how to use dimensions to sketch a solid. And if you look at the other example, it's talking about cross sections. Define arc of a circle in your own words. So we did that in lesson 3 of chapter 11. We also did that in chapter 10. But an arc of a circle would be the outer part or the portion of the circle defined by two endpoints. Again, it can be in your own words, so however you are going to remember it, you can write it down. So getting into some new vocab from chapter 12. The intersection of a solid and a plane is called a cross-section. When we're asked to find a cross-section, you're literally going to imagine that you're cutting the shape either horizontally, vertically, or at an angle, and then opening that 3D figure up. Whatever shape you see when you open those two would be the cross section. It's literally like if you were to take a piece of paper and slice through, what shape would be drawn on that piece of paper. The piece of paper would represent the plane, and the solid would be whatever three-dimensional figure you're cutting. A corner view of a 3D geometric solid on 2D paper is called an isometric view. So if you look at page 839 in your book, it says, in video games, 3D figures are represented on a 2D screen. You can use isometric dot paper to draw isometric views or corner views of three-dimensional geometric solids on 2D paper. If you look at the picture they show you, there's a front view, and then there's an isometric view. It's literally looking at something from the corner. On homework, I suggest that you go and you download isometric dot paper to do your drawings. It's going to make it a little bit easier. Cross-section is an expression that is used in everyday English. Either find the definition of cross-section using a dictionary or think of how you have heard it used outside of geometry. Explain any similarities between its everyday use and its use in mathematics. So if you look it up, you will get the definition from there, but you might know that cross-section is used to refer to a sample section or selection of a certain population, like when we're talking about taking any sort of survey. In math, if we're talking about a cross-section, like I said before, it's going to refer to a specific view or a part of or a section of some sort of solid figure. So I could say both ways are used to describe a section or specific view of something. Complete the graphic organizer below. Two different ways to draw an isometric sketch of a solid. One would be to draw an isometric view from the dimensions. And this is something that we mentioned at the beginning of the notes. So it could say something like it's 3 units high, it has two sides that are 2 units long, and one side that is 4 units long. That would be given the dimensions. Another way would be from an orthographic drawing. Again, if you look on page 839, it says recall that an orthographic drawing shows the top, left, front, and right views of a solid. You can use those orthographic drawings to draw an isometric view of a 3D figure. The top, front, and right views of a cube are shown on page 839. With an orthographic drawing, if you see one of the sides is darkened, that's going to indicate there's some sort of dimension here. So if this one was darkened, it would tell me that that is going to stick out in some way, shape, or form. Now let's practice with cross sections. Name 3 different cross sections of a cylinder and state how the plane would have to intersect the cylinder to get that particular cross section. Well, we could cut it horizontally, vertically, or at an angle. If I cut the figure horizontally with a plane, and I were to open it up, cutting it this way, no matter where I cut it horizontally, I am going to see a circle. Vertically, if I cut it this way and I open that cylinder up, I'm going to see a rectangle. You could draw these out. And at an angle, if I were to cut the figure this way and open it up, I'm going to see an ellipse. You might say oval, but the technical term would be ellipse. Look up the word isometry in the dictionary. Compare its definition with the definition of a corner view or perspective view. Why are corner views considered isometric views, but three-dimensional views are not considered isometric views? Well, if I look up the word isometry, an isometry is a distance-preserving transformation. Corner views are going to represent the actual distances of the figure. If I have a 3D perspective, the views represent the apparent distances of the figure. So if I look at page 839, at the very top of the page where it has the front view, the 3D view, and the isometric view, which would be the corner view, the isometric view is going to preserve that distance. It doesn't look as warped as that front view, that 3D view. So since an isometry is a distance-preserving transformation, we can say that corner view preserves the distance. It doesn't make it look as warped. Oops. So we don't have any formulas to fill in, but I do want to show you what isometric dot paper looks like. So I've downloaded an isometric dot paper here that looks like this. So beginning on your homework with number 1. It says a triangular prism that's 2 units high with 2 sides of the base that are 5 units long and 4 units long. Well, the first thing I notice is that it's a triangular prism. Prism meaning it's going to have 2 bases. So the base shape here is a triangle. So I'm going to show you how to do number 1. if it'll let me. Well, there we go. Okay, here we go. Oops. Okay, so number 1 says triangular prism 2 units high. So let's start with it being 2 units high. 1, there we go. 1, 2. Okay, then it says 2 sides of the bases that are 5 units long and 4 units long. So I'm going to go this way. 1, 2, 3, 4, 5. And this way, 1, 2, 3, 4. Okay, the bottom of the bases have to be the same, so this one's going to be 1, 2, 3, 4, 5, and 1, 2, 3, 4. Now I can connect these, 1, 2, 1, 2, preserving my height, and draw my line to connect the final side of the triangle. And I have a triangular prism that is 2 units high with 2 sides of the base that are 5 units long and 4 units long. So you can use the dot paper for all of homework, 1, 3, 5, 7, or you can just use it for the ones that make it easiest, which would be like 1, 3, 9, 11, and 13, whichever you prefer, but the dot paper does make it much easier. All right, email me if you have any questions, or we can go over in Zoom.